Tom Duggan shoots a rocket into the air from the ground at some velocity. It spends 8.4 seconds in the air before striking the ground again. What was its launch velocity from the ground? What was its height at the top? Okay. Now I saw him do this one time, so this is why I can write this problem, right? All right. So let's draw a picture of this, right? It's going to go up. It's going to go down. Okay. And the total time up and the time down added up to 8.4. So that means that it spent 4.2 seconds going up and 4.2 seconds going down. Okay. So the time is from the ground to the top, and that's how we have to take this thing apart. If we go from the ground to the top, which has certain advantages. Okay, if we go from the ground to the top, the time is that time divided by 2. Okay, so that devilry is just 8.4. So it's 8.4 over 2 is 4.2. Why are we dividing by 2? Because there's 2 equal parts. It goes up, it goes down, right? Okay. What was its launch velocity from the ground? Okay, so let's what else do we know? We know at the top that the final velocity, so the velocity at the top, is 0. Now it's 0 because if it's not 0, it's not at the top. Okay? I don't know what part of Britain that's from. All right, so what we know is that the velocity at the top is 0. We know that this is negative 9.8, right? We just don't know the initial velocity or the x. Okay, now we have to find the initial velocity first because we have no formula to solve for x that doesn't have the initial velocity in it, right? So let's find the initial velocity first. For that, I'm going to use no x. Is that right? Yeah. Okay, so I'm going to use this guy. Vf is Vi plus At. Right, so this looks like final velocity 0, so 0 equals Vi plus negative 9.8 times 4.2. All right, let's do this. Negative 9.8 times 4.2. So I get 0 plus Vi, 0 equals Vi plus negative 41.16. That's a 4, right? 41.16, right? Doesn't that mean that the initial velocity is just 41.16? The next mathematical step is you add that to both sides, right? So our initial velocity is 41.16 meters per second, right? We'd say like 41.2, right? And then it says, what was its height at the top? So to find the height at the top, we could use anything. I'm going to use this guy. I'm going to use that x is 1/2 Vi plus Vf times t, right? So x is 1/2. The initial velocity is 41.16. Final velocity is 0. Time is 4.2. By the way, any formula for x would work at this point, but this is my favorite one. So 0.5 times 41.16 times 4.2 is 86.436. That is a really tall rocket. Okay, 86.4 meters. And that just shows you that's just a fraction of what Tom Duggan can do, okay?